Good morning, students. Let us continue the chapter Thermodynamics. Earlier, we have seen first law of thermodynamics. What is the mathematical statement of first law of thermodynamics? The mathematical statement is del U is equal to Q minus W, where this del U is the change in internal energy, Q is heat supplied to the system, and W is work done by system on its environment. The first law of thermodynamics is stated as the change in internal energy of a system is the difference between heat supplied to the system and the work done by the system on its environment. So this is the first law of thermodynamics. Now let us see the sign conventions while applying this first law of thermodynamics. Let us consider we are having a cylinder, and gas is enclosed in this cylinder. This cylinder is having a piston, and suppose we heat this gas so that the heat is get added in this system. Suppose Q be the heat which is added in this system from the environment to the system, and when the gas absorb this heat, its internal energy is increase, its temperature is increase, the gas molecules they are moving with larger velocities, and that's why this gas is get expand. And when this gas is get expand, then the force is applied on this piston by this gas, and that's why the piston is moved in the upward direction. When piston moved in the upward direction, the work is done by the gas, and as the work is done by the gas, this is taken as positive. As energy is supplied to the system, this is again taken as positive. So here the sign conventions are this Q is positive and this W is positive. So this del U is equal to positive Q minus positive W. It is equal to Q minus W, same as the earlier case. Now let us see the second case. Suppose we are having this cylinder, okay, and this cylinder is filled with gas. It is having a piston. Now with the help of external agency, this piston is pushed so that the gas is compressed. This piston is now moved in downward direction. So the work is done by the piston on the gas. The work is done by piston. In this case, the work is done by piston. So the work done by gas is negative. In this case, the work is not done by the gas, but work is done on the gas. So the work done by gas is negative. And now let us consider that this cylinder is placed in an cold environment so that heat is get released from the system to the environment. In this case, as heat is released from system, there is decrease in internal energy of a system. Q is taken as negative. Now let us consider in first case, when the gas is heated, suppose we added 15 joule of heat, and at the time the work done by gas on this piston is 25 joule. It is like this is the system, and in this system we add heat from the environment. So how much heat we add? 15 joule, and this is heat is added, so it is taken as positive, and the work done by the gas. So this W is 25, and 25 is again positive of 25. What is del U? Del U is equal to Q minus W. What is the value of Q? Q is positive 15 joule minus W is positive 25 joule. 15 minus 25 is equal to 25 joule of heat is added in this system. And now suppose in the second case, when this cylinder is placed in cold environment, suppose that it loses 15 joule of energy. 15 joule of energy is transferred from system to the environment, so this Q is negative. And when this piston is moved in downward direction, work is done by piston, work done by gas is negative. And suppose in this case also 25 joule of work is done. This should be represented by system as heat is released from system. How much heat is released from system? 25 joule. And as heat is released from system, this is taken as minus 25 joule. And the work is done by piston on the gas. And as work is done by piston on the gas, it is also taken as negative of 25 joule. So we get del U is equal to Q minus W. Q is equal to minus 15 and W is equal to minus 25. Minus plus 25 minus 15 is equal to minus 25 joule. Minus 25 joule is the change in internal energy. The internal energy is loses by 25 joule. This is all about the sign conventions of first law of thermodynamics. Now let us move forward. Let us see the thermodynamic state variable. We know that in thermodynamic process, the thermodynamic state of a system is changed. When a thermodynamic process is occur, then there is change in thermodynamic state of the system. Thermodynamic state of a system is change means what is change? To know what is change, we must know what is thermodynamic state of a system. Thermodynamics state of a system. Thermodynamic state of a system is defined by values of state of measurable properties sufficient to determine all other properties. What is thermodynamic state of a system? Thermodynamic state of a system is defined by values of set of measurable values of set of measurable properties sufficient to determine all other properties. Okay, this is the definition of thermodynamic state of a system. What is thermodynamic state of a system? Thermodynamic state of a system is defined by values of set of measurable properties. Set, there is not a single measurable property, but there is a set of measurable properties. Suppose pressure, volume, temperature. These are the measurable properties, and this is set of these measurable properties. Thermodynamic state of a system is defined by values of set of measurable properties sufficient to determine all other properties. Now these three quantities are sufficient to determine all other quantities. Remaining quantities can be determined by knowing these three quantities. Okay, so this is the thermodynamic state. This is the thermodynamic state. This is, suppose this is the initial thermodynamic state, and the system changes from this state to some another state which is having the pressure P2, volume Vt, temperature T2. Okay, so these thermodynamics properties, they are get changed. There may possible that the volume remain the constant. Yeah, two properties are get changed and one property is remain the same. This is also possible. So this is the thermodynamic state of a system. Now in this thermodynamic state, this thermodynamic state is defined by values of state of measurable properties. What are these measurable properties? These measurable properties, they are known as the properties of a system. These measurable properties, this pressure, this volume, this temperature, they are known as the property of system. Now let us see the definition of this property of a system. This property of system, this pressure, volume, temperature, these are the properties of system. These are the measurable, these are the measurable variables. Now let us see the definition. Any observable or measurable variable, any observable or measurable variable that can be used to characterize the system, characterize the system when the system remains in equilibrium, when the system remains in equilibrium is called as property of a system. Now these are the observable variables, these are the measurable variables, and these measurable variables are used to characterize the system. These observable and measurable variables, they are used to characterize system. With the help of this observable, with the help of these measurable variables, one can characterize the system when that system remain in equilibrium. What is equilibrium? Equilibrium is one of the condition. In this condition, the system variables does not get changed, or the system variables, they are not having a tendency to change with time. That is known as equilibrium. What is equilibrium? Equilibrium is one of the condition. In this condition, the system variables, they are remain same, they remain constant. There is not any tendency to change these variables. The pressure, volume, temperature, they are remain the constant. So this is in equilibrium. Here we use the word to characterize the system. When the system is characterized, when the system is characterized by specifying the variables, then the system can be exactly replicated. When the system is characterized, now this is the system, this is characterized by these variables, this pressure, this volume, then this temperature, then this system can be exactly replicated. We know exact value of pressure, we know exact value of volume, we know exact value of temperature. So this system is get replicated by characterizing the system. So this is the property of system. The property of system is defined as any observable or measurable variable that can be used to characterize the system when the system remain in equilibrium. So these are the properties of system: this pressure, volume, temperature. This pressure, volume, temperature, density, etc., etc. These are the properties of a system. These properties of a system can be get classified can be get classified into intensive variables and extensive variables. Okay, what are the intensive variables? The intensive variables are those variables which do not depend on the size of the system. These intensive variables, they do not depend on size of system. And these extensive variable, they depend on size of system. Suppose we are having a system. Suppose this is our system. This system is having temperature T. This system is having pressure P, and this system is having volume V. Now we place a boundary. Then this volume is get divided into two compartments. This volume is get divided into two compartments, but the temperature is not get divided. The temperature, the pressure, they remain the same. So this temperature, this pressure, they are the intensive variable. They do not depend on size of system, but volume this volume that depend on the size of system. So this is the extensive variable. The volume, the mass, they are the extensive variable, whereas this temperature, pressure, density, they are the intensive variable. I think you got this. Thank you.